I'll pass it over to Rendy. You can introduce about yourself, maybe share your interesting about yourself too before you can start your presentation.
Sure. So yeah, my name is Rendy. Currently, I'm working at Ruangguru, Indonesian education technology company. So we have apps that students use to learn. And I worked before at Traveloka, as you mentioned before, we worked together for quite a while. And maybe one interesting thing about me is something on my desk right now. I have a debate with my daughter. This is a tree, right? It looks like a tree, right? She said it's a flower, and since she drew this, I think I lose the debate. It's a flower. So yeah, that's all. It's about perception, right? So yeah, okay, that's a thing about me. So I just start the presentation right away. So the discussion this morning is about Agile data warehouse development. What are the process and lesson learned? Actually, I've written about this some time ago, maybe 1.5 years ago in Medium, and we remember this and asked me to facilitate the discussion and start with some presentation. So I think just a bit of introduction. So the background first, we were rebuilding our data warehouse. So this is around my time at Traveloka. Traveloka is a travel company, and I started work there at 2013, and I worked there until 2019. So it's about 6 years, and I think in the fifth year, trying to rebuild our data warehouse for several reasons. I shortlist the reasons here, like save cost, fix data model, and also make our query faster. And also another background is, as we know, if you want to kind of like completely create data warehouse from scratch, it takes a long time, right? So that's another background as well. And usually the data warehouse is built on top of business process, right? And for startup, the tricky thing is sometimes the business process also changes. Like, okay, I have this product, and because of this product, the business process changes as well. And then, the data warehouse changes as well. That's also one tricky thing that we also have there. And the fourth background here is, Agile is widely accepted as a software development method. What if we apply the same to data warehouse, right? What will happen? What are the pros, cons? What are the good? More or less, this presentation will also talk about that. And in a way, I stumbled upon a reference on this matter, the book here, Agile Data Warehouse Design. We didn't apply everything in the book, but try to get the idea and experiment. And the interesting thing here is when I was the lead of the data warehouse team, Umesh is also the representative from data analytics team. If Umesh smiles, then maybe I lie or something, right? Just validate with Umesh expression. That's about a bit about the background. With disclaimer, as I said, this is a customized method. If you see that the book is different from what I say, that's because we just take the idea and try to adapt it to our situations. And this is by no means a perfect method. So this is just me explaining my experiment, or our team experiment back then. We will try to get a lot of lesson learned here so that you can avoid that in your each of your company. A bit kind of just to have a foundation on what we are trying to achieve. This is what data warehouse to me. You might have a different definition. There are a lot of definition out there, but in my opinion, this thing is something that our warehouse need to achieve. It has to be easier to use than raw data. Raw data means a lot of joins, and to do the joins, you need to know the context first. But with data warehouse, you are expected to know just the pattern. Like, okay, I need location, and maybe I need user. You then join with location and user as dimension. That's it. So if it's still harder to query than your raw data, then I think it's just you do data warehouse for no avail. And it's need to be easy to find and easy to understand where to look for your data, etc. And it needs to be trustworthy. That's very important, because if you create something and in the end analytics and data science don't want to use it, then it's just meaningless, right? So modeling principle matters, but in my opinion, achieving this goal matter most. So sometimes there are trade-offs in doing the modeling versus, okay, make it easy to use, etc. So we need to constantly making those decisions. And in a way, Agile helped to achieve this, because as an engineer, I tend to be idealistic with the design, but it might not be that easy for our user to use. So having a close collaboration with the user helped to validate whether the model makes sense or not. Okay, so let's go through the process of the Agile data warehouse development, and this is the overall workflow, right? The overall workflow is first, we define the metrics, just like conversion rate or I don't know, number of transactions per month or per day, right? That's the metrics, right? And after we define what are the metrics they would like to work on that iteration, then we do model storming preparation. I'll explain that later a lot more. And then we do the model storming session, where data engineers and data analytics work together to define what's the model that makes sense and needs to be rolled out. And after we create the final prototype based on input from data analytics, then data analytics can test the prototype. And if it is good, something good, then we implement and we turn the model, the prototype, into implementation to go to the final acceptance. So that's the overall flow. We will talk the detail of each of the steps, right? So first is about the iteration. So this is one iteration, right? The workflow is one iteration, and for each iteration, we define something called block. So this is a term that we define ourselves. This is nowhere, you can't Google search it. It will go nowhere, because we just think that if we work on one business process, it will be just too huge for us, because at that stage, Traveloka has a lot of complex business process already. And if we do just one business process, it involves a lot of data sources, like hell, a lot of data sources. So if we do one business process, it will be too huge and the iteration will take too long. But if we take one metrics, it will very specific to that use case only, means when we iterate, there will be too much overhead. So we try to look for the middle ground. We have a block which consists of several metrics, and these metrics in like part of one business process, right? So for example, for a transaction or sales business process, we take a look at what actually several metrics that can be, you know, grouped into one block, and then we work on that one block for one iteration. And to determine this block, data analytics and data discuss together on what makes sense. Basically, that's it. So first step is defining the metrics. This belongs a lot to data analytics team on what actually metrics that is important. So we create shortlisted metrics based on thousands of dashboard that we already had. What actually what are the metrics that is very important for us to see? And we start with that metrics. So we have I forget what's the term, Umesh. Something key metrics. So we start with those important metric, and we kind of like start iteration with that. This is just an example, yeah. This is I'm taking this from blog that I've written. It's already public. So one example for the metrics is conversion rate, number of population that converted from X to Y event. Like for example, from viewing products to buying the products itself, and it is applicable to be drilled down with the product interface or country. Interface here in Traveloka specific to like whether it's web, iOS app or Android. So it's like our media. And the product itself, like flight, hotel, insurance, etc. And of course, the country itself. So this is example of the metrics definition, and we take several metrics and group it into one block. And then we go to model storming preparation. And this is mainly done by data engineers. Once we decided, okay, we would like to work on these blocks, the first step is to kind of like figure out what are the data sources, right? Okay, we have these ABC data sources, and these ABC data sources coming from, I don't know, XYZ team. And some of them is similar, like, okay, this means transaction, this also means transaction, which data sources that would like to take for this block. So that kind of decision also happens in the model storming preparation. And we also make the transparent to analytics on what are the sources that we use. So we turn the metrics into the business process and the business process into data modeling, because those metrics relate to certain business process. So we define the grain, we come up with fact and dimension. I think this is the common steps on do the dimensional modeling. We do data source discovery, and then we implement an SQL view that is quick and dirty. It's just create an SQL view that is quick and dirty and easy to be validated. But this is still the heaviest step of the overall process, especially because we need to pick the right data sources. We need to apply the correct transformation rule to cleanse the data. So trying to figure out what the clean data is in this step. And after the model storming preparation, of course, the session itself between the A and the E. And what we do is we present the prototype data model, the schema definition. So as opposed to the book, which kind of bring business people, bring data analytics, bring data engineers, go to a room and then define the dimensional modeling with, I don't know, a lot of Sharpies on whiteboard. It's different from what we actually apply. What we apply is that the engineers come up with a proposal first, because we think that it would save time to come up with a proposal as a starting point for the discussion. And after we give the view, then analysts can query and fill the right away if this is off. This is something that is not I'm expecting because this is a wrong data source, or this is I can't drill down this way because of this, etc. So after we share the view, data analytics can come up with, and we can brainstorm on what makes sense. We can also share first, okay, this is the overall data model. We put order here and then items of the order here, etc. So data models, analytics can say that this is a bit inconsistent with the business, etc. And then give us feedback from data engineering. So that's the model storming session. And the rest, I just pack it into one slide. Prototype testing, we'll test the prototype and come up with other feedbacks, if any. And after that, we do implementation. And in this implementation part, given the right tooling, it can be very fast. And if the implementation is being done in a different way, it might be like hard or take a long time. So it's like the tool really matters in the implementation itself. It really depends on your situation, of course. And the last one is final acceptance. So in the prototype testing, analytics will have like several specification. Okay, I want to check whether the count match, and if count is different from source to target, what are the difference? Is it testing data or something like that? And those tests will be rerun to the final acceptance, and okay, this is something that already can be used for this report. It will be connected to the BI tools and being used for that report, and then the report will switch sources from the old one to the new one. So that's the overall process that is there. And when I talk about Agile with different people, like trigger different mindset. Some people say that it's fast. In my opinion, it's not really actually about being fast. It's about detecting your mistake early, getting to know where you got wrong and get that early, because the earlier you know, then the cheapest the mistake to be like fixed. And this is being done by involving data analytics throughout the process. When we plan the metrics, when we do the modeling and also the testing, we being very transparent with the analytics being familiar with the data that they are going to use as well. And we can respond to change. For example, one iteration to another, if there's another kind of like shifting in prioritization, the next iteration would be different. It can be different. And we have like something like tooling to have a working software over document. When we have a definition, when we have a rule, we make the code itself self-documenting. So for example, we have a regex to validate the value of the data, and it is embedded in the schema itself. I can circulate the presentation later, and you can just click the link. It goes to another Medium blog for Traveloka regarding Neo DDL. So we have a DDL that has some kind of data validation rule there, and also a description of the data. And of course, it encourages more interaction. As the process, as you can see, it's not like the data analytics is not only on the beginning and then at the end, but also throughout the process. So that's what we learn is we get more input, and the DA is familiar with the model, and it is tested by DA throughout the process, and also the right tooling will help the process faster. And I think this is actually where it is very interesting. We know when things goes well, words get around, but when things goes bad, this is something that we need to learn together. So the first iteration, I don't know, first 1 or 2 very long, because we are like trying to get used to the process itself. And the second thing is backfill is tricky because we are dealing with states, right? We are dealing with data, because we are dealing with data. Changing the logic means we need to change it historically as well. If we have the right tooling and also the right cost-effective tooling, especially, then it might not be a problem, but we still need to see the trade-offs, right? In each of the technology that you are using, whether it will be a problem or not. And the sprint size for one iteration can be totally different due to complexity. So for example, this block one is quite straightforward, or maybe there are a lot of tables that we need to make, but the data sources is straightforward. The cleansing rules are straightforward, but sometimes it's very complex and takes some time. So you can't do like software engineering. Okay, every 2 weeks we deliver something. It's tricky because the complexity of the blocks for one iteration to another is quite different. And it's not easy to estimate backlog because you don't know what you don't know. Sometimes you just go with the report, the current report. Everyone is happy with the current report. And when we dig deeper to the data source, we find something peculiar. Like, we shouldn't use this source. Like we should use this source. I mean, that kind of thing. There are two options, right? You can just go, okay, just go away with whatever we have right now. No one will care anyway. The number will be the same. But you need like also ask whether this is the right time to also fix this or not. So if the decision then, okay, it is intolerable, we need to fix this, then there are several additional time that is required to also take the data into the pipeline. So it's sometimes not easy because when you like trying to dig deeper, there's some surprises usually. Okay, I think that's all. Hui. I think let's just get back to you for Q&A. It's not a long presentation, right?
No, I think that's a good high-level overview. And then now we have time to dig deeper into that. Thank you. Rendy, maybe you could just open up the Slack and look through the questions.
Sure,
and,
sure.
Choose which one, right? If you don't mind, I'm going to throw out one here,
Sure.
which I like. How are modeling brainstorm sessions typically conducted?
Come again? You're breaking in the middle?
Scroll all the way down and look at Johan's question.
Okay.
Yeah.
How are end users input into the matrix definition incorporated into the process? The last one, right? Or no. So the Modelstorming session took place after the planning, right? So we have defined several blocks. We have defined several metrics that needs to be grouped together, and each Modelstorming session usually focus on that one block. So the answer is yes, it's focused on view specific metrics that we choose as one group because it's like just makes sense to be worked together. And how are it's typically conducted? Typically we the model that we have worked on, and what are the data sources and what are the transformation rules that we apply to the data. And then afterwards we ask questions, if any, and sometimes, if I'm not mistaken, we also share the view ahead. So analytics can check the data verse and come up with feedbacks or questions, so the session can be more effective. Umesh, do you want to add more?
I think you explained pretty well, really.
Okay.
That's more or less the process what we used to have.
Yeah. Should I pick the?
Yeah, feel free to pick anyone you
okay,
want.
Okay. Let's go with the most thumbs up first, right?
Yeah.
So what are the common missteps or antipatterns in terms of poor data engineering architecture? So I think when we are talking about data engineering architecture, there are two levels, right? Or two layers. The first layer is the infrastructure architecture, and the second layer is also the data itself, the data architecture, right? In my case, both are managed by data engineering. So if we are talking about infrastructure architecture, I think the antipatterns or missteps is there are a lot of buzzwords, so people tend to be cool, combining a lot of cool technologies. Meanwhile, it can be a lot simpler than that. So when I moved from open source big data environment into specifically, I just talk about this specifically BigQuery, a lot of them are simpler. So if we find a technology that just works for our use cases, we might be able to use just the technology alone. So it simplifies a lot in terms of data engineering infrastructure architecture. But if you talk about data model, I think the anti-patterns is to one extreme to be just let everyone to use raw data because it's not effective in a sense that it's costly, everyone trying to have their own version of the cleansed data, and everyone will debate about which one is the most correct one. And the next extreme is to have a very ideal data warehouse because it won't happen. It's just single source of truth where everything is very clean. It's just too time consuming to have if we kind of don't do it incrementally. Just have one business process, very clean, very ideal. In the end, everyone will have like a say to it. And sometimes it's just a matter of having a reusable data in data warehouse layer and something that is more specific for use case in data mart layer. I think, yeah, those are the in my opinion, the common missteps or antipatterns.
I have a follow-up question on that.
Sure.
Just do that same thing. When you said that we have two options, we have two extreme options, right? You can go from either exposing the raw data to creating a completely structured data mart and exposing only the process data. So when we use a self-serve analytics tool, right? What level of granularity would be recommended to showcase to the end stakeholders? Because we see that it's happening in Traveloka and many companies would be facing the same kind of challenges. And when you expose something like a transaction level, you see that the end user tend to join these tables with multiple different data sets, and it creates a kind of confusion because they tend to build the data mart in the self-serve analytics tools instead of having a proper data mart itself.
Okay. So what's the right level of granularity that should be exposed to self-service analytics tool, right? Yes, thank you. So I think that depends on how we govern the self-service analytics tool. This is just my opinion, yeah. But if we have the right self-service analytics tool with the right process, it might be okay to also expose the granular data, because this is the case in Ruangguru especially. So when we create the data mart, we make it exposable, we make it easy to find, so that if others try to reuse the data, they can try to look for the catalog first. So that might be one of the way to solve that problem. Make it very discoverable, make it very governed, so that it's very easy to use. But it's not always the case. So I think it really depends on what tools that you have and also the process that is there in place. In my opinion, not showing the granular data in some cases might make analytics hard to get insights from it, because okay, I'm just exposed to semantic layer, and I need something more detailed, and I need to go to the more granular data. In the end, it will be exposed, but having the right tool and the right process will really help.
Can I jam in on that a bit?
Sure.
Yeah, so I think it really depends on who are the target audience for that self-serve. For example, if it's just business side and like they cannot do SQL, then if we give them a bunch of raw data tables, it would be like dangerous. And also if it's data analyst, then what level of understanding for the raw data do they have? So I think like first, before we decide on what table we put into the BI tooling, is also training for them to how to get into the right questions and where to get the right data to answer those questions. Maybe there are so many data tables and they don't know which one to draw data from.
That's a very good addition to the discussion. Yeah. When we are talking about self-service, we need to kind of like really see what are our users, right? And different users will need different tooling as well, because the level of understanding on how to use the data. Okay.
We can't see you, Rendy.
You.
I think there's one next interesting question here. Pham asked, how do you enforce rule matrix X should not only be combined with dimension A? I think earlier you have a presentation, right? In your define the metric, you have a table. Okay, now we can see you. In the define the metric, you have a table. You say, hey, matrix, and then applicable dimension. So he asked about how can you do like dimension B and C should not be used together, or matrix X, Y, Z are not summable, right? It's the kind of distinct metric, that kind of thing. Yeah, where does that enforcement and logic be communicated to the end user?
I don't think we have solved that. So we have, when we like document the metrics, we have the notes in a column there, but I don't think it's being communicated that well yet to the users at that time. I don't know. Maybe it's better. Yeah.
Okay. Anyone else have any ideas?
So I have a question. I actually wrote a series about the book, the Agile Data Warehouse, and I noticed that there are a lot of diagrams. Like I think like the first half of the book, like 1/4 of the book is just, oh, there's this diagram and then this diagram. Do you use any of them, or do you find it completely useless?
I try to not do the process just for the sake of the process. So I try to see what actually they sense. So the answer is no. I just say, okay, this is the parent, this is the goal that they're trying to do, and this is how they do. And this very complex process won't work, and it's just not the good fit for the organization. As we're trying to do something simple, right? So no.
Got it.
Yeah.
Awesome. Yeah. Pick another one.
Sure.
Regarding to data engineering, but what do you use or find to be effective for a pipeline orchestration tool?
Orchestration tool means something like Airflow?
Yep. What is working for your use case?
So the one that works for the use case, it was Airflow that I was using. Yeah, so I think it works quite well in terms of defining the dependencies and also ease of monitoring, especially if I look out there, the monitoring tools, the dashboard, I think Airflow is still one of the best. I see there are several things that is quite new in terms of orchestration, especially in terms of like dependency management. If you have ever heard DBT, right, that build tool, it's like you just create SQLs. That's why in the presentation I said with the right tooling, everything gets easier in the implementation, because if you just do something like DBT, you just define the SQL from the view going to the implementation, it won't be that different. Yeah, I think for orchestrating, if you are talking about like scheduling, management, monitoring, I see Airflow is one of the best. And for dependency management, I see DBT is quite promising. Meanwhile, I myself haven't used it in production, just playing with some use cases. But yeah, I think that's worth for you to look at. Anyone would like to add more? Maybe?
You use DBT for data transformation also. Oh, okay.
No. You asked me whether I use that. No, I don't. I haven't used that yet. Yeah, because it requires a lot of changes. If you don't build from scratch, or you're trying to do something like rebuilding data warehouse, then it will be quite tricky to like add that as part of the overall dependency that's already there.
Okay. So what do you use at your previous work or currently for data transformation?
So mainly we use BigQuery for data transformation. So SQL to SQL transformation.
Like you just write Python or whatever wrapper around that and hook the Python script into Airflow?
Correct.
Okay.
Correct. It includes several wrappers. If you would like to have a different country handler or different, so it's like templating SQL wrapped by Python in a way, because SQL alone, it's quite hard to maintain. It needs several additional seasoning based on your use cases.
Got it. There's a question here. How do you handle PII data? Do you need to in your case? Yeah,
of course. So I think the earliest effort that we do for PII is trying to mask that. So we just do something like hashing. of course, the detail of the implementation can't be shared, but it's just trying to hash so that it reserves several statistical properties like uniqueness, right? You want to know whether there are different unique, I don't know, something government issued ID. In Indonesia, it's called KTP, but it's unique ID that government issued for you, right? Let's say that's the PII. If you mask that, in some ways, if you are trying to retain the statistical properties, then it has several values there, like for example, uniqueness, etc. And you can actually try to extract out something that is not that specific for that people. Usually from the government issued ID, there are several parts that talk about in which district are you on, something like that. That's not really personally identifiable because there are so many people in that district. So yeah, that's how the first step is masking. And of course, the next step would be like doing encryption, having the governance. We have several, I think we have CDO, Chief Data Officer, approve the usage of the personal data. It needs to go through certain process. And if it approved, then we decrypt the data and join it with the real data that they have, etc. So I think the very first step, if you haven't done that, then just try to do masking. It will be very helpful, not only for you, but also for your user, because your user also only need what they need. Having specific information in analytics usually not that useful. We need aggregates, we need to see the trends. So yeah.
So you're saying that there's so most of the data is PII mask, and then whenever there is a need from any particular business team that require the actual data, they have to go through a approval process with the CDO, and then I guess in the data warehouse, do you maintain, I don't know, a dual a mirror table with the raw PII data, or how is that structured?
So what we do is have the mapping. We don't have the mirror table, but we have the mapping.
Okay.
So it's if we map it back, then it will go to the right person, and if it is decrypted, so we don't mirror it because that's just too much. So we have the mapping somewhere else.
Okay. So what kind of security clearance? Like who are the people in the team typically who have that kind of security clearance? Is only the CDO have access to the underlying tables, underlying raw mapping table and the raw information, or would there be like a small team that have access to that?
Small team.
Okay.
A small team, because the engineers in the end have access to that, right? But a small team have access to that, and from management point of view, it's just the CDO. It's the idol.
Cool. Guys, if you have any question, feel free to just unmute and ask. It will be more lively. There's a question here about okay, sorry, go on.
Are there any difference in terms of implementation for big data analysis and querying for the warehouse thing? Are there any difference in terms of implementation and usage for big data?
Is there any different implementation use case for big data?
Yes, because I heard in some places if they want to query or work against big data, they exclusively use data from S3 and do something with it, but not straight from a database.
I see. Okay. So this is interesting actually. I think there's a good podcast about this one. There is one expert that actually pro to having everything in the data warehouse appliance. I forget what's podcast, but this is a good one. And the second one is someone that is pro. Everyone will eventually go to having a data lake and the big data storage like S3, etc. And it's like never-ending debate. But in my opinion, personally, I tend to put everything structured into data warehouse appliance, especially because cost-wise, it's actually similar right now compared to before. I used to put data for data warehouse in Redshift, and it's a lot costlier for the same size. But in BigQuery, it's a lot cheaper, and I think the cost of the storage is the same with S3 or GCS, Google Cloud Storage, S3 for Google Cloud. So in terms of that one, I don't see any difference, and I feel that most of the data is structured, so I put most of the data in BigQuery. I still use S3 for video, images, something unstructured and not even text. Something structured, unstructured but still text, I still put it in data warehouse. So it's really have different opinion, but it's for me, it's easier if everything is in data warehouse. Even for something that, you know, a bit unstructured, we do put it as a JSON column and just go with it, right? But something that is not even a text, like music, videos, images, then I put it on something like S3.
It's called the data warehouse versus the data lake.
Yeah.
And then, you know, when everyone keep arguing, some guys just came and say, guys, stop debating between the data warehouse versus the data lake. We have the data lake house. No, that's true. You guys, if you go on Google, yeah, so the data lake house is essentially this Databricks guy. He's been pushing for data lake, and then, you know, he's like, okay, maybe we're pushing for the wrong thing. We should invent the data lake house, essentially a data warehouse inside data lake. So then you can store all your data on your raw data in the data lake, but then within the data lake there's a small data warehouse.
Interesting.
It's a fun thing. So yeah, Rendy, you talk about the podcast A16Z.
Yeah, I put that in on the chat.
Yeah, but FYI, A16Z also invested in Databricks, which is the company behind the data lake house. So it might have been media manipulation as well. So we'll see.
We'll see. Interesting question, by the way.
Awesome. Let's take maybe two more questions, and then after that, I think Rendy, there's all the question there. You can go into the chat, and then you can respond in line so that everyone can review them as well.
Sure.
Yeah. Anyone have any question you want to ask?
Yeah, I do. So questions from me is that what is your QA process whenever you have create a new table?
Okay, in the model storming process, the testing happened twice. It was when the prototype is shared, and second is when the ETL implementation in place. So, you know, the result of the ETL. And for each of the process, the one that is being checked is quite similar. Of course, we check the numbers, whether the source to target mapping is correct, whether there's no missing data at all. And second, we also check the trend, the business. People that analytics team spend a lot of time with the data, and they will feel something off if they see the data. I think this hotel transaction is not this much, for example. So those feelings is also very important for us to have an alarm in a way there. And of course, in the end, we put those thing into something like for alerting. Like currently in Ruangguru, we are also using assert command in BigQuery. So in BigQuery, you can have a query to check a query. Sometimes it sounds silly because query itself declarative, so you like declare it twice. But in a way, the assert one, the testing one, is something is more specific, like you see the count, whether it matches or not. We also do some simple anomaly check. For example, if somehow the transaction is just half of the last week at the same day, maybe something is wrong, right? So we put something like that as well. But in terms of the QA process, most of them take a look at the numbers and also the business context around that numbers.
Yeah, that makes sense. Thank you.
So I have a question, Rendy. How much more you mentioned earlier about you have the model preparation, model storming preparation, and then the model storming section, and then after that, once people agree and you test it out and prototype, it's all good. You do the actual implementation. Go into the detail of that, meaning that in the preparation phase, do you mean to say I just create a SQL view, right? So then just to get the logic right. But then people will query it, but it might be slow. It's the actual implementation phase. And what happens at each phase?
Okay, my experience with that is different between Traveloka and Ruangguru. So in Traveloka, what we do is we implement that into several layers. So we have a layers that does the cleansing and the layers that most of the times does join, like combinations, right? So from the view, we then convert the logic into those two layers. First one is to Spark job. No, Apache Beam actually. Yeah, in the end, it's going to data flow, and then the second one is trying to combine the logic, right? So that's what I've done in Traveloka. But in Ruangguru, most of the logics is in SQL. What is different from the implementation, view and implementation is not much actually. The view part that is maybe different is how we structure the pipeline, because some intermediate table is reusable for other retail as well. Right? So instead of having different views going their own pipeline, we might have intermediate table, and this intermediate table being reused by several final tables. And another thing is we also use several UDFs. So this UDF wrap the reusable logic of your SQL. For example, if you would like to check whether this internal email or not, is it a valid phone number or not, which happens a lot, separated in several SQLs instead of having each of the logic being copy pasted here and there, we collect into UDF. So the key in the implementation usually is more about designing the pipeline so it's easy to manage, designing the reusable codes there for the same reason, so it's easy to manage, and also for cost effectivity and also performance. But usually for performance, it's not that different because there's not much that you can do with the tuning, etc. because it's, in my opinion, efficient already. Like for example, in BigQuery, what you can do is doing partitioning of the data. When you are talking about view, it's not partition. You can take, for example, specific start date and end date just for that view and agree, okay, we will have the view from 1 January into 31 of January, 31st of January. That's all. But when we put it into implementation, we need to take into account the partitioning of the data itself so that it's cost efficient and also fast to query. Yeah, I think those are.
Okay, so to summarize, essentially, in the preparation, all the logic is actually done and accurate, but the implementation is really more about optimizing for performance, optimizing for cost, and optimizing for reusability and maintainability.
Correct.
Okay, sounds great. I guess one last question before we end the session. Damn, I forgot. Yeah, you mentioned earlier that in Traveloka there was a bunch of, I think, Spark data flow and all that, and in Ruangguru it's mostly SQL. Correct. But my question is, if you were to do again from the beginning for both Traveloka and for Ruangguru, which approach would you have chosen if you were the choice to start from fresh for both companies?
Mm-hmm. I feel the Ruangguru one is simpler because I started in earlier phase of the company itself, so there's not much to fix there. But yeah, I think I prefer to start with a lot more SQL, and if I need to improve there, I totally will check out DBT or something similar because it's a lot more natural to have SQL resolve their own dependency and have a specific part to take care of the materialization, etc. I really would like to test that out and see whether it's something that, because if it happens to work, it will make the implementation a lot more efficient as well.
Okay, so what you're saying is, or rather my follow-up question will be, do you think that at the scale of Traveloka, a similar SQL-based implementation would work at the beginning and scale along the way up until the current stage?
I think yes.
Okay. Umesh, any comment?
Actually, we are moving more towards DBT. I don't know if Rendy is aware. So our finance data map is completely built on DBT. And even for corporate analytics, we started extensively using DBT. So for finance, I think if you look at the data volume is almost in pair with the other products itself, because we have the core payment data mart built using DBT, and it's been running for almost 6 to 8 months now, and it's been pretty stable. So as an organization, we are still debating, should we move away from Dark Phoenix, which was basically developed by Rendy and his team, to move towards DBT, or we have to maintain, because the data engineering team is more comfortable with Dark Phoenix, whereas the finance FinServ team is more comfortable with DBT. So it's a debate that's going on currently.
Interesting.
So one is more Python programming oriented, one is more SQL oriented.
Yeah, that's correct. And the interesting thing is, like with DBT, we see that even analysts can schedule their jobs with a little bit of an exposure, and instead of relying on schedulers like BigQuery scheduler, which is not very highly reliable, if they are able to upskill and do their own scheduling using DBT, I think that's quite reduces the dependency on the data engineering team itself. So in our case, especially on corporate analytics, because we didn't have a dedicated DE, so we decided to learn from the FinServ team, and we moved all our jobs from BigQuery scheduler to DBT scheduler now.
Awesome, awesome. All right, any last question? We can close up here. Okay. Anyway, thanks a lot, Rendy. I think that was great sharing. Yeah, I think you managed to take the entire Agile data warehouse book and simplify it, apply you and your team and Traveloka experience, and invent a new one, a derivative one on top. So that essentially we don't actually need to go and read the book anymore. All right, thank you, Rendy.
Okay, sure.
Thanks, guys, for joining. Just stay in touch in the Slack channel. Rendy will actually go and answer the questions there. If I have any question to answer, just shoot it there too, and then I'll see you around Slack.
Okay.
All right.
Thanks, Rendy.
Bye. Thank you.
Thanks, Rendy.
See you.
Thank you.
Thanks,
Bye, everyone.
Bye.
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 Everyone.